Hi, welcome to Digital with Darren. I have a master's degree in physics at Imperial College London and graduated in 1997. I designed satellites at Matra Marconi Space, and I spent 20 years as a quantitative trader on proprietary and flow trading desks in the City of London. Right, so today we're going to go through the Pythagorean triplet question, which is a daily coding question. And here it goes. Basically, given an array of integers, determine whether it contains a Pythagorean triplet. And the clue is that we have to recall that a Pythagorean triplet, ABC, is defined by the equation a squared plus b squared is equal to c squared. So, the first thing that we have to do is define an array of integers. And do this on line number 16. We just say let array of integers equal, and then we pass in an array that we choose to investigate. The next phase is to create a function, and the function will take in the array above, which is this array of integers, do some operation on the integers, and then produce a result which is either true or false, such that if this triplet is found, it will be true, and if the triplet isn't found, it will be false. Now, the creation of a function is just like this, and we'd name our function. I've named the function below p triplet, but just by way of example, we'll give it a name. Have a name, and then we'd have some parameters to the function, but this particular function is only going to take in one parameter, and it's the array of numbers. So in this case, we might call it a array of numbers. The function is then going to do some operations. The function is then just going to return a result. And the return value will either be true or false, depending on what will happen. So inside the function, we're going to have an if statement determining some criteria. And in the criteria, whatever that might be, some criteria. The determination of this will result in the trueness or falseness of the function. So we might have an extra item going before the if statement, some kind of logical test. And we might set that initially to be false. And the return result would then be logical. This logical test. And in the if statement, we might be asserting something like logical test is true under certain conditions, otherwise it's false under other conditions. So if this condition is satisfied, I'm just going to put it in quotations although it wouldn't be, but if this condition was satisfied, then the logical test might be true, and then we'd return true. So I'm going to delete this. The next thing that we know we need to do is to test for all of the triples in the array. Now let's just pull this site up here. So if we pull this site up and expand it, There's a pre-built algorithm or pre-built library in JavaScript. It's in the node package manager, which is this npm over here, and in npm js.com. And this particular package is for combinations and permutations. It's actually called js-combinatorics or combinatorics. And basically, it's a simple combinatorics like power set for combinations and permutations in JavaScript. And what we're looking for is one of these functions to see if it's useful. And it's got its usage here. Here we see you've got a power set, but we don't want a power set. We want lists in threes. But on the next one down, we see that we've got combination, and it's written in this form. So we let some variable equal combinatrix got combination. We put in the array, and then we put in the number of items in the array that we want combinations of. In this particular example on the website, they've used 2. So we get AB, AC, AD, BC, BD, and so forth. If we were to put 3, we'd have had ABC, ABD, and so forth. So this looks like it's going to be appropriate. So let's get rid of this site and then continue on with the programming. So I'm just going to comment everything out here, completely out to this array. Even everything in the example commented, just to show how this combinatrix function works. And the first thing we had to do was require it. So we do const and then some variable, whatever we wanted to call it. I picked a suitable name, which is combinatrix, but you could have just used C, for example. It could be anything. Equals, and then you do the require in JavaScript, and then you do the function that you want to require, open quotation, and JS. And we see in the list here, if we scroll up and down, you can see that js-combinatorics is one of the it's one of the packages that's already I've installed it. And in order to install it, you just need to go into here and do npm in a terminal. In any terminal, you need to go into npm and then install, or in install, and then the package name js dash combinatrix and so forth. And it will just run it in the node package manager, which will be added into the list of packages that you could use. Now, once that's done, so we've done that, and once we've set our array, which we've done already, we then just want to do just to check that it works. So we can now call this. So we could say C, or let C equals combinatrix dot, and then these are the functions that are available in combinatrix, and the one that we wanted was combination. So we do combination, open brackets, and we're going to pass in our array into this thing. So it's array of integers, and then from this array we wanted lists of 3, so we just put in 3 into this argument here, and we just want to see what we get. So now it's going to do something, the way that this package works, this particular things, and this is in other languages too, but for combinations and permutations, it's quite processor intensive for large array sets that go in there. So rather than computing a whole array and passing it directly into the memory of the computer, which would be quite inefficient, they compute them on a one-off basis and work out the next calculation. So what we'll see when we do here is we'll probably see an address. So if I do log of C, let's just see what we get and hit F5. And we get this here, we get this number 10. So We know that it's yielded an answer, but we just know we don't know what it is. It's gone into memory. And in order to see it in memory, we would need to possibly do something like c dot for each, run a for each loop. And then in the for each loop, we'd want to run a function that does a console.log for each item in there. And then we might be able to pull it out. There's a little trick here. It's called an arrow function. And it's for each element in there. So we'd put in element, for example. And for each element, we would want to do log to the console of the element. So rather than just logging to the console and getting the array address, we'd get each element that was in there. And let's have a look and see what happens when it is run. And here we go. We see that we do get, in fact, a list of all of the combinations here. We get 1, 2, 3, 1, 2, 4, 1, 3, 4, 2, 3, 4, and so forth. And there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of them. So unsurprisingly, this number of 10 is actually the 10 items. So we know that this function works in the way that we want it to, and now we've just got to try and implement it into a function that is useful for us. So the next thing to do is to get rid of this for each, because it was by way of example. We don't need to log to the console, and we are going to uncomment all of the pre-commented lines, because we will be using this code. In fact, this code is the answer. And we've declared our array of integers. We've got that there. This is what we're going to inspect. We've pulled in the require js-combinatorics methods that we need, the particular method that we're going to use. And we need to call it. So we've got that library and we're going to call it. And we're going to do this by creating a function, and we know how to create a function because we just saw that before. We write function and then the function name. So in this particular case, I've called it p triplet for Pythagorean triplet. And then inside the brackets is the parameter that we want to pass in. And it's going to take the argument. So the parameter takes the argument from something that feeds it in, which will come from here in this line, but we'll come to that later. And then we open up a block of code with the open braces. Now, the parameter that we want to pass in is a, and in this particular case, and you can see this in the little comment that I've put just above the function, and the reason why I put this comment above the function is if we hover over it with the mouse, if you comment in the right way, you can actually describe your function to a user or another programmer that might be reading it. So here we're saying at parameter a, it's an array of integers, and it returns, the function returns a true or false. So we take in this parameter a, which is this array of integers, and the first thing we might want to do is log it to the console, just to check that it works. And here we write the array to inspect is, and then a, and that should log something to the console. The next thing we do is we set our output to false, because what we want to do is we want to determine if this works, it's true. So in all other cases, it's false. Do we find a Pythagorean triplet, or do we not find a Pythagorean triplet? So if we do find it, we're going to change that status from false equals to true. And if we don't find it, the status is just going to remain false. The next part of the function is what we looked at just before, which is this combinations and permutations. And here I've written get all the permutations, but it's actually going to be get all of the combinations. It's worth looking up the difference between combinations and permutations, but they are different in what they do. And permutations, it takes in it's a different function. So do look that up. they are actually different, and you'll get a whole different list in the array if you were to do that of results, and we don't want that. We definitely want combinations in this particular case. We want unique combinations, and we want to test for each of them. So we're going to have fed in some value, and we saw from above that when this value was fed in, the algorithm that's written in the Node Package Manager module produces a set of triples, and we're going to want to test for each of these. So we do this cmb.forEach because we're going to go through each one of these, and it's going to do, I've called this small set because they're sets of 3. So we've taken this array, and in this particular case the array was 1 to 5 long, but it could have been like 10 long or 20 long or anything, any length. And we're going to go and we want to get these arrays that are of length 3. So we do that, and we know that we're getting 3 because the second parameter that's in here, we've defined it to be 3. And we've defined it to be 3 because we want the a squared plus b squared and c squared. We don't care about all of the other variables in there. We were looking for the Pythagorean triangle or Pythagorean triplet. Now, we square each one of these values. So, again, in this particular case, I've just chosen to define a squared, as in the small set squared. And the way the first element of the small set, if we look at our code, we see that each set here is of length 3. So element 0 is 1 here, element 0 is 1, element 0 is 1 here. If we go down here, element 0 is 3. In order to call the first element, we're calling it small set of 0. And then these two times signs here means to the power of, and then 2. So the first element squared, the second element squared, and the third element squared. So that's what we're doing. We've got a squared, b squared, and c squared. The next thing that we've got to do is to test each of the arrangements of a squared plus b squared plus c squared. And that's just done by a simple if statement, and I've repeated this if statement 3 times. And the reason why is you can get a squared plus b squared is c squared. Then you can get a squared plus c squared is b squared. And then you can get b squared plus c squared is a squared. So they're the different combinations that we've got. And then this statement just runs in this particular way. And I'm going to write one out just to show you a blank if statement. But if, and again, we've got our condition in here. And then we've got our block of code in here. And that's what I've done. And inside the if statement, all we're going to try to do is to find, is our triplet condition satisfied? And what we're looking for is if a squared is equal to, and notice the double equals here, it's not assigned to, we're checking that it's equal to, and that's how you do an equals to in JavaScript, as well as many other languages, a double equals. So when we've got an equals here, it doesn't actually mean the mathematical equals. It means, in this particular line here, it means small set of array number 2 squared is assigned to the value of CSQ. So here we're checking that it's equal to, and if a squared is equal to b squared plus c squared, we're going to log our value to the console, and we're also going to change the status from output equals false. We're going to assign it, notice the 1 equals now, we're going to assign it the value of true. So whereas we started with, before we were entered into this for loop and testing, we assigned output to the value of false, and it was residing in a false status. If this is now true, it turns into a true status. We have found a Pythagorean triplet. Now, if a squared plus is not equal to b squared plus c squared, we then check for the next option, which is b squared. Is that equal to a squared plus c squared? And we do the same thing. We will log an answer to the console if it's true, and we'll output it if it's true. We use an else if statement for that. And then again, we look for the third condition, and again we do it with an else if. We could just keep doing if statements, but the else if bypasses the first statement. It's already assuming the first one hasn't been satisfied to get there. So if this one hasn't been satisfied, then this block is run. If this block hasn't been satisfied, then this block runs. And in each case, if it does get satisfied, the output is true. And finally, we come out of this and we return the result. Now, the return of the result is either going to take the status of true if one of these conditions at any point in time was true, or it's going to remain at false. And that is the entirety of the function. So let's just run this function, and we're just running it at this point in time with an array of integers of 1, 2, 3, 4, 5. And I just happen to know that a Pythagorean triangle, I believe it's 3, 4, and 5. So these three should be found. 3 squared is 9, 4 squared is 3 squared is 9, 4 squared is 16, 9 plus 16, so 3 squared plus 4 squared is 25, which is equal to 5 squared. So 3, 4, 5 is a Pythagorean triangle. And if we hit F5, we should observe that something is found if the code works. Oops, let's see it. And here we go. The code is run. I'll just run it again so you can see it actually running. And we can see that the array to inspect is 1, 2, 3, 4, 5. And that came from our function here where we just logged to the console. The array to inspect is A, and that's 1, 2, 3, 4, 5. And then here we get the triplet found. So one of these loops found the triplet. One of these if statements or else if statements satisfied the condition and produced the triplet found a squared equals b squared plus c squared. And the output was set to true, which is here, return output. But in order for this function to have actually run, we needed to call it. And we called this function earlier on in this line here. We let this variable, which is triplet, be equal to or assign the value of the function p triplet, which we created below. So this is the actual function that we created down below. And we're calling it and we're passing in as an argument the array of integers. And we can see as I double click on it, you can see the array of integers comes up here from this line. So this array of integers is passed into the function. This function then executes its code. The result of the code is either a true or false. And if we hover over the function, we see it returns a true or false. The true or false is passed into the is triplet variable. And we log to the console at the end contains triplet. And if it's true, we're going to yield the result true. And that's the final line. And that is how to test or create a little function and solve for the Pythagorean triplet. Thank you for watching. So, thank you for watching my video. I hope it was helpful. And if you did like it, then please press the thumbs up like button and also press the follow button below. I will have more programming videos and also some trading and math ones to come too. Thank you very much.